So how was the homework? So you should hear me now, right? Okay, I'll update the form that accepts the homework so that it takes different file types. And also I increased the file limit. A minute, I'll do that now. Google Drive. My Drive. That is a different account. Okay, I'll solve the homework now. Anyways. So 2 people responded for the homework. 3 people. Let me see the names: Shahd and Amro and Omar Alaishi. So let me change the. Okay, it accepts all things. No. So you can try to re-upload the homework again, and now it accepts everything. So send. Okay. It should be working now. Okay, what else? So let's try to solve the homework. Let me share the screen. Share screen. Start broadcast. Share. Okay. PDF expert. And oh, here it is. Rename. Lesson 2 homework. Then let's duplicate it. Okay. Okay, let's do it. Is my voice lagging in any ways, or is it good? It's good. Okay. No, it's good. It's fine. Okay. Very good. So find HCF and LCM. I think these questions were easy to check. Shall I solve them? HCF and LCM, it's very easy, straightforward. Shall I solve them or skip? Okay, easy. Let me choose a nice color to solve. Okay. easy, easy, and easy. Okay, convert the following to recurring decimals. 0.4. I think it's a bit easy. You will say that 10x is equal to 4.44444. Then x equals 0.44444. So 9x is equal to 4. Then x is equal to 4 over 9. So B was a bit tricky, right? Mu'mina, the homework was blank for you. Okay. I'll try to send it as a PDF on the channel itself. Okay, okay, number 0.9 dot. So it's a bit tricky. Okay, okay, we say that 10x is equal to 9.9999999, and x is equal to 0.9999999, right? So we subtract, and we get 9x is equal to 9, right? So x is equal to 1. Okay, so let's see what's 0.9999 up to infinity. Any infinity here is actually equal to 1. And it's very close to 1. So basically 1 is just actually it's 1 is sort of very close to 0.999999999. So actually it's 1, because these nines don't end. So actually there's sort of somehow there's no difference between this and this. So basically, yeah, 0.9999 bash. It's 1 because infinity sort of causes some problems. So it's 1, yeah. Okay, good. 0.31, we would say that 100x. Did you get the 0.9 bar? Did you get the answer? Okay. Okay. 0.31 bar would be 31.31313131. Then x would be 0.31313131. You would subtract 99x would be 31. So x be 31 over 99. You can always check your calculator, your answer from your calculator. Okay. Okay, 0.45 bar. I used a different sort of notation here explicitly, so that you understand that these are the same thing. Okay, so it'd be pretty easy. Let me get the back color again. Okay, 100 x would be 45.45. Then x would be 0.4545454545. Then 99x would be 45, and x would be 45 over 99. Okay, let's go a bit further. So this is a bit tricky. Number E is a bit tricky. Okay, number E, were you able to solve number E? It's a bit tricky. Okay, anyone else from Omar and Kunuz who are sort of clever people? Mu'mina, did you solve number E? You didn't even see the homework. Okay, so no problem. I solved it. You solved. Okay, good. Anyone here from Egypt? Okay, حبيبي أحمد. Okay, very good. So speaking English is okay, right? Yeah, okay, good. So I'll skip I'll skip number E. It's similar. It's okay. No, I'll do number E. So number E, we will say that we need to multiply it by how much? Let's multiply it by 1, 2, 3, 4. I think 4. Yeah. Let's multiply by 1000x would be equal 7 so 0 3 okay, so that'd be 31.3131131 and x is equal to 0.031. So this is not correct. No. Not correct. This is not correct, right? Yeah, so multiplying by 1,000 is correct. Incorrect. Incorrect. So let's multiply it by 100. So 100x would be 3.131313. Okay, and x would be 0.0313131. So these will cancel out. So yes, this is correct. So x is equal to 99x would be equal to 3.1, which is equal, so x would be equal 31/990. Did you get it? Okay, very good. So regarding people from Egypt, anyone here from Manor House School? Manor House? It was my school, so I'm just asking if anyone's from Manor House. So anyways, not an important question. So number F, it's basically the same idea. Shall I solve it or? Okay, you live in Saudi Arabia. Very good. So shall I solve number F, or was it straightforward? Skip if you want. I can do it quickly. That's what I'll do quickly. So I'll need to multiply by 1,000, I think. Yeah. Okay, let's try to solve it. So let's say 100 x would be 2.0406406406406. Then x would be 2.406. So this will not work. Not work. Cause they will not cancel out. Work. Recurring decimal. Oh my god. Recurring decimal will not go away. So let's try it by 1,000. Let me solve it. So 7x would be 2 point, no, not 2. 20406 no 0.6, then 406 406 406 6, and the x would be equal to 0.0406 406. So these will cancel out. So yeah, 1 minute. These will cancel out. And we get okay, 2. I need to. So 999x would be equal to. Oh my god, my handwriting is very big. 1 minute. Let me zoom. So this would be 203 8.6 would be equal to 999x. So x is equal to 20386.6 divided by 999. Okay. Why there's no dot above 0? Because this is the number. There's no dot above 0. Yani the thing that repeats 0 does not repeat. 0 does not repeat. Only repeating. I can, yeah, because it sort of, I tried to, I actually wrote it beside it. So basically, the dots are between 4, 0, 4 and 6. So 4 and 6 repeat. So anything between the 4 and 6 will repeat too. But here we don't have any dots, right? So anything between the 4 and 6 will repeat. It's similar to writing it like this. 1 minute. 4. But I wrote it like this to sort of to let you ask this question, actually. To let you know that if we have a dot above a number, then a dot above a different number, then anything between them would repeat. Did you get it, RGB? So actually, I wrote it this way to sort of, for that you asked this question, and very good that you asked. Yeah, you asked this question. So I think G and H and I are easy, right? Easy. Okay. So this is the tricky part. Okay. You're with me, guys? Okay. So calculate the following. Leave the answer as a fraction. So what would you do here? What did you do? An MSE. Okay. Minus first. Okay, actually, it can be solved very easily. First of all, you convert to fractions. Then subtract fractions. Yeah, so basically 0.02 is equivalent to, a minute, it's equivalent to what? probably, let's convert, let's solve number A here. So 0.02 dot is equal to, let's say 100x is equal, let's say 100x is equal to 2.2222222, and x would be equal to 0.02222222. So 99x would be equal to 2.2, because these will cancel out. So x equal 2.2 over 99, which is equal to 22 over 999. Okay, is it easy up to now, right? It's easy, right? Okay, so you get this. That's 0.02 dot, then 0.01 dot would be equal to 100x, which is, I'll solve it very quickly. So x99x would be equal to 1.1, x would be equal to 11 over. So basically, to solve this, we have two fractions. We will just subtract the two fractions. So 22 over 990 minus 11 over 990. The answer would be 990. And 22 minus 11 is equal to 11. No, not 1 over 9. It's 11 over 900 over 990. So you understand how, you understood how I solved it. Basically, you convert the recurring decimals to a fraction, then subtract the two fractions. Did you get it? Okay, let's take another example. So 0.45 over 99. So okay, 0.045 minus 0.31 bar. So 0.045 bar, that would be 45 over, let's see. Oh my God. 45 over, I think 990. Let me check. I'm not sure. Let me check. Calculator. Okay, yes. Minus 0.0 minus, oh my God. Minus 31. 31 over 990. So that would be 990. 45 minus 31 is 14. Oh, okay, yes. Momena, there is no difference. They're the same. But take care, Momena. When I say 0.0201, here's a dot and here's a dot, that's equal to 0.0201 bar. 1 minute, let me be very accurate. So yeah, 0 does not repeat. Why recurring decimal lesson is not in your book? It should be it definitely should be in your book. You're using what book are you using, RGB? You probably you're probably using notes. So if fourth edition, I think. Okay, I think I'll recheck the syllabus, but they should. I'm using the third edition, I think. Cambridge IGCSE third edition. It's there, but I think it's in the syllabus. I think it's in the syllabus. Okay, what about Cambridge 50? Okay, recurring. So let me share the screen on my computer. Share screen, continue. So yeah, here it is. Share. As you can see, okay, includes the conversion of recurring decimal to fractions to a fraction. So this is the syllabus. So yeah, it's coming. It will come in your exam. This is the syllabus. The Cambridge IGCSE Mathematics 0580. So for examination in June, November 2020, so and 2021, 2022. Also available, okay, for India only, we don't care. Serve decimal. Let me find the word recurring. Recurring. Here's recurring decimal. Yeah, the third edition is also made by Rick and Terry, so I don't know why didn't they include the recurring decimal, but it's there. Anyways, it's in the syllabus, so you should know how to solve them. Okay, stop share. Let me share here. Screen. Okay, very good. So any questions regarding the homework? Okay, we solved number B. Is number B clear? What book do I recommend? I honestly don't like the book that I'm reading. It's not very organized. So I can't really give a very good recommendation, but actually the most important thing is that when you come to the past papers, you're able to solve everything. It's not about which book should I use. It's what can you solve everything in the past papers? Yes or no? That's sort of the most important question, because the examiner won't ask you what book you used, but it will ask you it will ask you about solving the question in the past papers. So the past papers are the most important thing. And actually in Egypt most teachers don't use books. The thing that I don't like, but they use notes, and people actually at the end of the day get good grades. So the choice of book is not that important. It's good to have a good book, but it's not the most important thing. The most important thing is that you solve a lot of past papers. Okay. So was number B clear? Shall I proceed? Okay, so you understand you need to convert to fractions, then subtract the fractions. Let me write it in sort of, actually I'll write it as a text. Here. Text number 1. I don't like this one. Oh, okay. Convert to fractions. Then number 2, subtract fractions. Okay. Done. Okay, done. Yes, Homer. Okay, Omar, let me sort of turn off. I did the same as you, but it took too much time and it was a mess. So basically, no, you should. It's pretty straightforward. You should sort of 0.01. You should convert them to fractions, then subtract fractions. That will take no time, and without any mess. Actually, number B, I took the answers from here. Yeah, where I calculated them on the fly. So now that's solve number E. That's solve number E. So 0.27 bar, that would be equal. A minute. That would be equal 27 over 99 minus 106 bar. 106 bar, that would be 106 bar, 106 over 990. Let me check. 106 divided 999. 1999. So you need to sort of get a common fraction, get a common. You need to get a common denominator. So that would be 1 minute 99 times 11. 99 times 11. So 99 times 10. So actually, that would be a very big number. C was, yeah, it's a bit long because you need to get the common denominator for these two numbers. I'll just search for the LCM of these two numbers. LCM of 99 and 9999. Okay, so basically it's 10,989. So 10,900. So that would be, you multiply it by a very big number. Oh my god! Because actually, I think I shouldn't have put this very long question. 99 times 11, yeah. So 27 times, oh my god, 2997 minus 11. Okay, very good. So this is 106. 106 times 11. 106 times 11. Okay, yes, that would be 100. 1166. So the final solution be something like this. This is not a decimal, take care. This is my handwriting is horrible. Okay, 2997 minus 1166 1831. Okay, good. Thank you, Kunuzia. Sir, I don't understand E. Okay, very good. Okay. Number E. Let me erase everything here to sort of solve it again. Number E. So number E, we will convert these two numbers into recurring into fractions. So convert 0.27 and 0.106. Two fractions. Okay, Karma? Then after that, Then subtract the fractions. So when I converted 27 bar to fractions, that would be 27 over 99. Then 106 bar over, that would be 106 over 999. So the answer would be, so in order to sort of subtract them, I have to have a common denominator. So I got the common denominator, which is this one, this number. Then I subtracted the numerators, and that was the answer. Okay, good. So let's go to the today's topic. Okay, good. PDF. Name. Lesson 3. Notes. Oh, okay. Lesson 3. Notes. Okay, lesson 3. Notes. So today we'll be talking about accuracy and today we will talk about accuracy. Accuracy. Let me get the book. Desktop. Oh, here is the book. Extended one, the normal one. Okay, accuracy. So, okay. So let me say a story. Assume you go to the mall. Yeah, you go to the mall, and you want to buy the following. Number 1, a watermelon. Number 2, a golden necklace for your mother. Okay, so you go to the mall and you want to buy these two things. A watermelon from the grocery store. And okay, a golden necklace for your mother. So basically, you go and you see you found a sort of an 8-kilogram watermelon. And the guy weights it, and let me try to draw it. Okay, that's the watermelon, and that's the. I need to make a better drawing. That's the. Here's the watermelon. Let me have a green one. It's 8 kilograms. Oh my God. 8 kilograms. Actually, it was a good drawing. Anyways. So you got an 8 kilograms. Then you go to the. Then you go to buy the golden necklace. Okay, and it looks like this. Stem, I love you. I love you. And it looks like this. Okay. Are you with me, guys? Okay. So the guy weighs the the golden necklace, and okay, let me try to. No. Here's the one. And it says about something like, okay, 11 grams. So what is the difference between this and this sort of waiters? What's the difference? Any idea? Okay. Okay, we're good. No, okay. What? I didn't mean to ask this question, but what's the difference between this weighing machine, and this weighing machine? Any idea? Okay, very good. 1 in kilogram and the other is in gram. So basically 1 in kilogram. There we get. Okay. Kilogram. Kilogram. Gram. Okay, very good. So actually, the watermelon is measured in kilogram because I don't need to know the. Okay, Okay, thank you, Kunuz. Very good. That's the conclusion that I want to reach. So the kilogram, we don't need to measure the watermelon and know how many grams exactly it has. We just need to sort of know the kilograms. It's just 8 kilograms, 7 kilograms, 9 kilograms. But when it comes to the golden necklace, I need to I need to accurately know the weight of the necklace because each gram will sort of cost a lot of money. So the 1 gram difference will be sort of, well, I know the price of gold now for in Egypt is about 1 gram of gold is equal to sort of 800 EGP, which is about 150 Saudi riyal, I think, or 170 Saudi riyals. So it's a lot of money. So what actually 1 gram will buy sort of 10 or buy 5 or 6 watermelons. No, not about even it will buy about 20 watermelons or so. So the gram will make a very big difference. So these two raters are sort of these two machines have different accuracies. Have different accuracies. And you understand why I need to measure things differently, right? Okay, thank you. You understood why I need to measure things differently, because something like watermelon, we don't need a lot of accuracy, and something like golden necklace, I really need a lot of accuracy to measure it, because that small difference would make a big amount of money. That small difference would sort of make a big difference money-wise. So, okay, in many instances, we don't need to know the exact number of the exact weight of a watermelon, for example, but we need sort of an approximation. So for the watermelon, what we did for the watermelon was an approximation. We approximated let me get a small thing. Very good. We made approximation. Here we made a more accurate approximation. So you understood why we need accuracy and approximation and so on and so forth? Okay, very good. Let me move forward. So when I approximate something, what I do is I round it up. When I approximate, I somehow remove some numbers from the exact value. So basically I round it up a little bit. Okay, assume rounding. So we go to, accuracy, we understood approximation. Rounding. So the watermelon example, back to the watermelon example, actually, if we took the watermelon and weighed it on the golden necklace on the golden necklace machine, what would be the actual weight of the watermelon? It will be something like this: 8.0013, well, actually 8,011 grams, right? Or anything. So actually, but I don't need to know all of these information. I don't need to know the exact answer. So I just need to sort of round up the weight of the watermelon. So to 8 kilograms. I don't really care about this minute difference, right? So I will just round it up. So basically rounding, you can, assume you're, for example, a football stadium. You're in a football stadium and there is exactly about 28,617 people in the stadium. So I want to round them to the nearest 1,000. What would be the answer? Okay. To the nearest 1,000. Actually, the answer would be to the nearest 1,000. So I'll take here and check. A minute, let me begin. Okay, so 28,617 to the nearest 1,000, 10,000, 3, 100, 4, 10. So we use to the nearest 1,000. So I'll check 28, 1. Then I'll check this term, the 1,000 term, and put sort of some bar here and see, is this number less than 5? Less than 5? If yes, no. If yes, then I'll add it. I'll add 1. Don't add 1. Don't add 1. Less than 5. Yes. Add 1. No. Do nothing. Don't add 1. So is 6 more than 5? Oh, yeah, less than. Very good. Less than 5. Less than 5. Yes. So basically, it's less than 5. Sorry. I messed up. So 1 minute. Very sorry. Very sorry. If it's greater than or equal 5. Greater than or equal 5. If yes, no, add 1. No, do nothing. Nothing. So is 6 greater than 5? Yes. So I will add 1 to this, to the 8. Add 1. So it'd be 29,000. Is it clear now? Yes. Okay. Good. So to the nearest 10,000. Okay. So this is the 1,000 term. This is the 10,000 term. 10,000. By what I mean by the nearest 10,000. Okay. Let's sort of explain what's 28,617. Actually, 28,617 is equal to 28,617 is equal to 20,000, right? Plus 8,000 plus 600 plus 10 plus 7. Am I correct? So this is the 10th. Oh my God. This is the 10,000. This is the 1,000. This is the 100. This is the 10th. I can't remember. And the 7 is just the nearest. I can't remember. No, I think whole number. Whole number. So when I get it to the nearest 10,000, I'm talking about about 20,000, 30,000, 40,000. When I need to the 1,000, 8,000, 9,000, 10,000. When I'm calling to the not 10, 8, 7, 6, or even 10. But anyways, or 100, then I'm talking 600, 700, 800, 900, and so on. Then 10, 10, 20, 30, 40, and yes, ones. Here's ones. Ones. Thank you, Ahmed. So you got it? So when I'm talking about 10,000, I'm talking about what? How many zeros? 1, 2, 3, 4. So here, to the nearest 10,000, I'm talking about 4 zeros. So I go here. 28. 4 and check. So 2. Here's 2. So 8 is greater than 5, right? Greater than or equal 5. Add 1. Add 1. Add 1. Equal to 29. Sorry, that will be equal 30,000. Okay, very good. To the nearest 100, what will we do? We will check 28, 617. So 28. To the near 100, so I'll check 20 here. And 1 is actually smaller than 5. So do nothing. Wait. To the nearest 10. So do this. Then check the nearest 10. Is 7 greater than 5? Yes. So it'd be so you got the point, right? You understand me now? Okay, let's go further. Okay. Rounding. Okay, decimal places. So after actually explaining these two things, okay, so there is something called to the nearest decimal. Okay, let's see decimal places. So you understand how to round in sort of integers, not decimal places, right? I don't upper and lower bounds. I don't think we will have time to discuss upper and lower bounds, but I think I'll probably be making another lesson in the middle of the week, probably on Wednesday. But I'll tell you on the channel. I'm not sure about that yet, but I'll make another lesson in the middle of the week, inshallah. Okay, so decimals. A minute, rounding in decimals. So 0.1234567. So this is called a minute. Rounding to the nearest decimal. It's called once, I think. Not once. This is called tenth. 1 minute. 10 color. Oh my God. Tenth, then hundredth, thousandth, ten thousand. You should notice the th, right? Tenth, hundredth, thousandth, 10,000th. You notice the th, right? So if we want to round 0.1, 2, 3, 4, 5 to the raised 10th, it will be 0.12 to the nearest 10th. Nearest 10th. Let me check something 1 minute. Rounding. Oh, 1 minute. Sorry, I messed up. 1 minute. Sorry, I messed up. Okay, this is the 10th. This is the hundredth. Hundredth. Thousandths. Okay. Then 10,000ths. So I messed up. So this is the nearest tens. This is the unit, decimal. This is the units. And this is, okay. So let me explain it again. So 1, 2, 3, 4.1234.5. That would be unit. Sorry, not unit. Decimal. So that would be to the units, tenth, tens, hundreds, thousands, and that would be this tenth, then hundreds, and thousands. Is it clear now? So let's express 1,2,3,4.1234 number I to the nearest tenth. So 1, 2, 3, 4 point to the nearest tenth to 0.1. Then I'll see 2, 3, 4. I'll see. Is this greater than 5 or not? No, so it will be 1, 2, 3, 4.1. Let's take another example. 0.9561. Okay, number I to the nearest hundredth. So we will do like that. 6 is greater than 1 than 5, then I'll add 1, that would be 0.96. Number 2, to the nearest hundredth, to the nearest hundredth, thousandths, that would be 0.9561. Then I'll check here. It's greater than, it's less than 5. So it will be equal 956. Okay. So what if we want to do to the nearest tenth? Number triple I to the nearest tenth. 0.9561. One is incorrect. So 1 wrong. It must 1.0 correct. Okay? 1 is wrong. 1 is wrong. It must be 1.0. Okay? 1.0. 1.0. Don't forget the 1.0. Yeah, you wrote it correctly, but RGB wrote it incorrectly. So it's 1.0. 0.99 to the nearest tenth equal 1.0, not 1. If you're 1 in the exam, you'll get 0. So you need to write 1.0. Why, sir? Because 1 is written as no, 1.0. It's written to the nearest tenth, but 1 to the nearest unit. Here, remember this. So I can't say that they actually, when you write 1, I don't know that it was 0.95. Mr. We can you give an example about irrational numbers? What do you mean about irrational numbers? Okay. Pi. Okay, let's take pi for example. Pi is equal to 3.1415229. Okay, it's irrational. Let's round it. Round pi to the nearest 1, to the nearest ones. 3 to the nearest 1, that will be 3. 3 to the nearest tenth, that would be 3.1. To the nearest hundredth, 3.14. Thousandths, 3.14, let's say. Then it has a 2 here, so it will be 2. Very good. So you understand rounding, very good. So what's the difference between these? What's the difference? What's the difference there? Okay. Okay, more accuracy. So actually, we have more. We got a name for significant figures. figures. Yeah, more significant figures would be more accuracy, but this is called one significant figure, two significant figures, three significant figures, four significant figures. Yeah. So as we go down, we have more significant figures. So basically, numbers can be approximated to a given number of significant figures depending on how much accuracy do I need. For example, if we need to calculate the circumference of a table that you have in your home, circumference of a table. Circumference. Is it very important that we calculate it very accurately? The circumference of your table, home table. We don't need to calculate it very accurately, so we don't need a lot of significant figures. Don't need accurate calculation. No need for a lot of significant figures. But for example, if you are if you want to calculate the radius of the moon, radius of the moon. You need more accuracy. Therefore, more significant figures. You got me? But keys but I don't understand your question, Knuz. So we use rounding to get the desirable number of significant figures. Length of keys accurately to it's not, you need to calculate accurately, but not very accurately, you know. You can just use by 3.14. Yeah, I got the point, but you don't need it very accurately. You need a bit accurate, but not very accurate, as much as you need to sort of calculate the radius or sort of the circumference of the moon. You need, for the moon, you need a very good accurate accurate approximation. But for the table, circular table in your home, you don't need a very accurate approximation, right? So let me sort of solve one question regarding the significant figures. Then we will sum up because I need to catch the pairs. So let's say let's take by 3.141529. Write it to 3 decimal places. Okay, 3.142. Okay, write it. Right, sorry, right. It to 3 significant figures. Okay, so you got the difference, right? Okay, very good. So I think I'll continue explaining it in another lecture, and I'll explain to you, I'll explain to Kunuz why we need. Actually, when we're sort of making space measurements, we need to have very high level of accuracy. So we need sort of, they use pi in sort of, they use a lot of significant figures in pi because they need a lot of accuracy in calculations regarding space in general. However, when it comes to your home, you don't really need some sort of very complex calculations. So you can just use any sort of you can just use a not very accurate level of pi. When will we have the next? I think we can try to make it on Wednesday. We will try to make another lecture on Wednesday, so we have 2 times per week, not just 1 time per week. So sort of we can sort of finish the syllabus quickly and solve a lot of past papers. So yeah, for today I'll be giving you I'll be giving you the homework, and it will not be a very long homework. No, homework will not be long. A WhatsApp group. Actually, I can't make a WhatsApp group because I'm very busy. So I'll make a Telegram bot. If you want anything, just send it to me on Telegram, and I'll respond via the bot. Or you can just use my. The previous time it was very long. Okay, I'll make a shorter homework. Don't worry. Okay, what else? I think we're good now. We can conclude and go. The submission, I already solved I made Google accept anything, Google form accept any form of submission. So we try to submit and it should be working well. Anyways, I've seen your homework here, Kunuz. Yeah, I downloaded actually, but you already have the answers, so you'll be fine. And the submission, I'll make the Google form accept everything, inshallah. Deadline is before the next lesson. So if we're having a next lesson on Wednesday, then the deadline will be something like on Wednesday before the next lesson. I'll send the answers to the last homework. Yes. So see you soon, guys. Thank you for attending. Bye bye.